Okay. All right. First up, just a reminder, we're open, we're shipping fast. We need your orders. We want to keep doing this.
And we've got freebies.
Yeah,
Free
and
STEMMA.
we have freebies.
Sweet.
So don't forget that.
Yeah.
Okay, first up.
All right, first up, we've got, this is going to be, I think, a very popular one for the people who need this kind of thing. You have an I2C connection, and, you have maybe 1 foot of cable, but what if you want an I2C connection that goes 100 feet? What do? I2C normally isn't designed to handle cables that are 100 feet long unless you have one of these LTC 4311 active terminators. This thing is really cool. So this is what your I2C normally looks like, right? You've got the pull, there's an active pull down, so that's the straight line of the sawtooth. But then when a device wants to release the bus, because remember it's a shared bus system, the weak pull-up is what brings the signal high. And if you have a very long connection, that capacitance coupled with the resistance of the pull-up creates that RC constant, which is what you see in the sawtooth wave. There's also some resistance of the cables as well. So you can mess around with the resistance, make the resistor smaller, so that will reduce your time constant and make your sawtooth wave a little bit less sawtoothy. But at some point, you're just fighting the capacitance of the cable, and you can't make the resistor any smaller. That's where the active terminator comes in. Plug it in, and this chip will automatically detect that the SDA and SCL pins are starting to come up. You can kind of see it curve at the beginning of the sawtooth. This chip will kick in and dump a ton of current in and pull that line up solidly all the way, so you get a nice square wave. So if you look at this demo here, what we've got is a trinket connected to an OLED display and then the active terminator below it. And then on the right, we have the I2C pins connected through an Ethernet cable that's 100 feet long to a BME 680. And when as long as you just set the I2C frequency to about 100 kilohertz, which is kind of standard on Arduino anyways, you're able to communicate with all 3 devices, even though there's this 100-foot cable. So this is a perfect perfect add-on to your I2C devices when you have long sensor distances. It's plug and play with STEMMA. Just put it at the beginning of your chain. If you have questions about the capacitance and how the current draw, whatever, check the data sheet, because it doesn't act as a I2C device. It just sits on the bus and just helps it along. It's a little helper. Next up, a respin of one of our favorite old products, product 390. One of the first ones we've made, that's a really old product ID, was our USB DC solar charger. And it's done us very well for many years, but I wanted to upgrade it, first up because I wanted to put USB-C on it, but also wanted to see if there were some other chips that had come out in the meantime that could improve the capability of a universal charger. So what I did is I found the BQ24074, put on a breakout board with 2.1 millimeter DC jack, USB Type-C, 2 JST outputs, and this is a really nice universal charger. So let me tell you what it can do. You can use any DC power from 5 volt to 10 volts, so that's higher than our previous breakout, which maxed out at 6. So you can go up to 10 volts. You can. It also has input protection up to 28 volts. USB Type-C connector makes it easy to plug in power from any wall adapter or computer. It'll use 5 volts off of that. If you want, the D plus and D minus pins, those are available also, so you can kind of chain this into a dev board. The output, there is a charge port. The charge port can charge up to 1.5 amps, which is pretty high. Very handy when you've got one of those 2,000 or 3,000 or even 6,000 milliamp hour batteries. You want to charge a little faster. This will do 1.5 amp charge rate. You can also set it to 1 amp or 0.5 amp, or if you want, just cut the jumpers all together and put in your custom resistor. The output is load shared. So if you plug in the battery into the charge port, the output port will always have no more than 4.4 volts on it. And it will automatically use the USB or DC power if that's available, and only supplement it with battery power if you end up drawing more current than that's available from DC and USB. So basically, it tries to not drain your battery. If you have a USB or DC plugged in, your load will never be higher than 4.4 volts, so it's good for 3.3 volt linear regulators. It's also good for up to 5 volt boost converters. It's a nice voltage. You'll have automatic load sharing up to 1.5 amps. It's got an optional thermistor input if you want to use a thermistor. There's a power good LED. There's a charge LED. Best of all, it works with solar without needing any extra capacitors or anything. It's got a built-in capability to automatically reduce the amount of charge current so that the voltage doesn't collapse. It's like an input dynamic power path thing that's built into this charger chip. So if you use a solar panel, I just plugged one in, it'll automatically draw as much current as it can, basically kind of like a max power point type thing, before the voltage dips below 4.5 volts. So you get the most current output. It's nice and stable, it doesn't oscillate. So this is a great universal charger. Even though it works with solar, you don't have to use it with solar. DC power, 9 volt, 5 volt, USB-C, all works with it. So it's like an all-in-one, everything you ever wanted to charger. Next up, Matrix Portal. We've been doing a lot of Matrix projects, and I wanted to make it easier to build some of these internet-connected projects. Historically, we've used a Metro M4 airlift and an RGB matrix shield. So this breakout plugs into the back of a matrix and does it all. So let me grab one and I'll show it off. Overhead. Okay, so what we've got here is a SAMD51 Cortex M4, so it can run up to 200 megahertz. Type-C, everyone's like, when are you going to do USB Type-C? Okay, now, everything is with USB Type-C, okay? Leave me alone. ESP32 as a Wi-Fi coprocessor, so that lets the SAMD51 do all the LED matrix driving and a CircuitPython or Arduino code, and all the Wi-Fi and SSL stuff is handled by this chip. Level shifting, onboard SPI flash, breakouts for analog pins, UART, SPI, all that good stuff. STEMMA QT connector, so you can use any of our 50 plus boards on it. 2 user buttons, side buttons, and then 1 reset button that's kind of recessed. JST port, and then these 2 little SMD hex nuts. Basically, they're soldered onto the PCB, allow for power, so the power comes in from the USB-C, or you can apply power here if you want, or through the connector. And it's like no soldering required. You basically, this comes already attached, this header. This header plugs into any Hub 75 RGB matrix, which is kind of like every RGB matrix. Every one that we sell is Hub 75. You can use it with 16 by 32 up to 64 by 64. So it's got the extra address E pin. So if you want to use it with 64 by 64 matrices, it'll work. And here's a demo. It's just going online and getting the price of Bitcoin. Congratulations, it's about $11,000. So this is running CircuitPython. So it's very easy to make RGB matrix projects. You can chain the matrix. In this case, there's only one right now attached, but you can make a long string of RGB matrices as long as you don't run out of memory. And the SAMD51 has 192K, so you're good for quite a bit. And we have a really great new library, sorry, let me just focus lock. The Proto Matter library, which runs on this SAMD51 and is optimized for driving these displays. So you get like these beautiful, colorful displays. Almost no work required. And now you don't even have to solder, don't have to worry about the wiring, because the wiring is the hardest part of using these LED matrices. People always, it's hard to mirror it and you get it wrong and it has to be a certain pin and the clock has to be on the same port. It's all taken care of, just plug and play to make internet connected LED devices.
All right, next up.
Next up, this is a 1.25 millimeter pitch connector pair for inline connections. People who are doing wearable projects or lightweight projects or the stuff that goes into drones, they want very small, thin connectors. These are Molex PicoBlade compatible. You get 1 socket, 1 plug, I think like 10 or 20 centimeter long polarized connectors. You can use them power or kind of anything you want. And we'll get some more pin quantity ones, but we're starting with 2 pin.
Okay, next up.
Ooh, this is something you like. You like these security cables.
Yeah.
So this is a cable that's a USB-A to USB-C, so it's good for like, charging or using with your phone or whatever, your USB-C, or your Matrix portal, which is now USB-C. But in the middle, there's a switch, and it can change it from being a data connector, like a sync cable, to a charge cable. So if you want to charge your device from an unknown charging source, and you want to make sure that there's in no way accessing the data on your phone, which is something you have to worry and think about these days, like you don't have enough to worry about. This cable has a little switch in the middle. You flick it, and it goes from data, where the D plus and D minus pins are connected, or charger, where they're disconnected. That's it. We already have versions of this for like USB to micro B. Now we have USB Type-C.
What's up?
We have another soldering iron. I always like these pen type irons that have built-in temperature setting. So this one is from ATTEN. They make really nice soldering irons, and it's got a little LCD with buttons on it, so you can set the temperature right on it. It's a pen style, so it plugs right in. You see it's nice, easy to use display, and it's like 60 watts, which is impressive. Usually you don't get pen type irons with so much current. It's a little bit big, but for a pen type, because it has to be so powerful, just plug it into your 120 volt power, and you're good to go. I think it's a great toolbox iron, or beginner iron. It's inexpensive, and I like that you can adjust it from lead free to lead solder, and it works with any Hacko compatible tips.
Next up.
Next up, never stop stemming. That's what you tell me every morning, and I have not stopped since. So this is another stemmification. The TSL2591 is a long-standing Lux light sensor that we've had in the shop for quite a while. This is product number 1980, a good year for breakouts. Now available in STEMMA QT format. Plug and play, it's the same price. You get the same sensor, same schematic, still 5 volt or 3 volt usable. I2C is level shifted as well. And it's plug and play, so you can use it with anything that has a STEMMA or STEMMA QT or Qwiic connector. We also have adapters, so you can use these with Grove devices as well.
Okay, and the star of the show tonight, besides you, Lady Ada, team, community, the customers, is we have, I'd say, like the early release, the first round of
Yes.
the BrainCraft hat.
We do. I just put some in stock, so and I haven't notified many of the back orders. So if you want to pick one up, now's a good time before we notify people. We finally have the BrainCraft hat. This was almost a year in the making. Things got a little bit complicated in New York for a few months. It got delayed. So it's supposed to come out in March and it didn't. But it's out now. So the BrainCraft hat is our idea of how you want to make machine learning projects for boards like the Raspberry Pi. I went through and actually made a bunch of projects, and
Spotlight.
yeah, hold on. I'll show this off in a moment. Paintbrush lighter.
Yeah.
Maybe I'll point it at itself. So we wanted to make something that makes it easy to do machine learning projects. So I actually went and built a bunch of projects using TensorFlow, using Google Assistant, using Alexa. And it's like, okay, well, what did I learn from all these? What is the things that would have been really handy while building these projects? So for example, TensorFlow Lite runs on a Raspberry Pi 4. So there's a Pi 4 underneath here. And there's not a lot of, this room is a little busy. So instead, I got this iPad with a picture of a tiger, and you can see it's like, hey, I see a tiger. It doesn't know that it's a photo of a tiger. It thinks it's a real tiger. That's cool. And
If you're worried about tigers, a photo of a tiger, that works.
yeah, that's fine.
It's neat. It says windshield, and then before you glanced over at the mouse, it said mouse.
Mice it actually usually does recognize. Yeah, there you go, mouse.
Yeah. Tiger, mouse.
Tiger and mouse. So two great things that go great together, except for the mouse. So what? I'll just point this up at the ceiling. So to do vision projects, one of the things I noticed is that it was really annoying to do them without having a visual representation of what's going on. So in order for people to make easy projects, I decided, okay, let's put a little TFT display. So the display shows exactly what's on the camera, what the camera is seeing. Hopefully it'll say like human or something. No, I'm not human. This game does look like a window shade.
Window shade.
So it's got a display, 240 by 240 display for showing what is on the camera. It can also show you the frames per second. I've got the fan off, so that's why it's telling me the power is dipping a little bit.
Yeah. Let's see if it knows this thing of hairspray.
Hairspray. Syringe. Lotion. Okay, lotion.
Not bad. So that's, everyone's favorite hand sanitizer. And it recognizes
iPod. Okay.
Yeah.
I can see why it's
pretty close.
So having the display is really helpful, so you can do vision projects. There's a slot here for a camera, so you can use the Raspberry Pi camera with it. I'll do this little tape thing, so a little bit nicer. There's 3 dot star LEDs. There's a 3-way joystick, and there's a button, so you can use that for audio projects. We'll show that. There's 2 JST connectors, so you can connect servos or relays or NeoPixels. That's something that actually the folks at Google TensorFlow said would be awesome. Like they're like, oh, I want to have a way for you to do machine learning, and then it controls a relay or a servo or a motor some way. So we made it so it's plug and play. You can plug in here or plug in here to connect another device. There's 2 speaker ports, and I can even try connecting the speaker. And let's see.
Yeah, here's the cool thing. One of the things that we wanted to do is
Tiger.
It talks.
It talks.
So it just said tiger.
I have to look at something else for a little bit,
Yeah.
and then it's like, oh no.
Tiger.
Demo died.
Yeah.
I think because it's actually not connected to a good power source. All right. See, this is the risky thing about demos. But when it's connected to a good power supply, it works fine. There's also a headphone output and 2 microphones, so you can do audio recognition projects. And most importantly, there's an on-off switch for the audio. So if you want to ever make it so it's definitely not listening, this will manually disconnect the power from the audio circuitry. So it's definitely not listening to you, which is something that you've always said was an important part of machine learning and audio recognition projects.
Yeah, well, here's the thing. Just let's imagine a world where Google and Amazon Alexa and other permanent microphone devices in our homes had a switch, a physical switch that you knew when you switched it off, it wasn't listening.
Yeah.
It would the amount of like PR damage that's done every day and every year for these types of devices, and how oh yeah, by the way, an employee's been listening all the time. All these things that come up over and over. I think the adoption of these things would happen faster, and it would be like, hey, we're thinking about the user. So when we do these types of devices, we're gonna have an off switch.
Audio on, audio off. And it's mechanical. It's not like a mystery. It's
not a screen thing. It's a physical switch.
No, it's a physical switch.
What does a physical switch cost?
This is like 15 cents.
Okay. I think it's worth it.
It's worth it.
I think it's worth it.
Yeah. And then on the back, one of the things that we spent a little bit of time going is I didn't turn it on because, again, the power supply I had here wasn't as good enough. But one thing that we noticed is when you're doing especially video recognition projects, the Raspberry Pi can start to overheat. So we added a fan that attaches onto it, and then when you plug it in, it turns on the fan, and it will cool down the Raspberry Pi so you can run your projects longer. We definitely noticed when we were running it for 15 minutes, it wasn't a big deal, but when you're running it for an hour, the Pi slowly heats up. So there's a fan that comes with it as well. So this is early release. We got a few in the shop. It definitely works. I'm writing up the guide. It'll be live probably tomorrow or early Friday morning on how to get everything going. And it works with our existing TensorFlow Lite project guide that we published. And we also published a guide on how to use Teachable Machine from Google to create a TensorFlow Lite file that you can then run on a Raspberry Pi to recognize custom objects. So, yeah, I think it's kind of cool. I think this will make it easy for people to start exploring TensorFlow Lite and other machine learning projects. Like I saw today, there was a project I made with a Pi that recognized license plates. And I think when you have a standalone computer that can do some of these projects, they might take off.
Yeah, and here I feel terrible because I do, because normally for a product like this I would be doing a big launch and everything, but like it's been terrible.
It's been a year. I mean, like,
It's-
yeah.
I would have like a bunch of things going on with this launch, and so we're just gonna launch it.
We're just going to launch it because you know what? I was going to
But-
wait, but then I was like, you know what? Let's just get
Yeah,
it
there
out.
was a couple friends of the company that I wanted to get them one, but it's just like we just literally got finished making these today. So, anyways, I feel like I failed.
didn't fail.
But no, I did.
We're gonna
but,
do
but
more.
you didn't. No, the thing is, like, I'd rather instead of like trying to be perfect, let's
Yeah.
just get it out there.
Here's the thing: we're gonna
As
do
far as
guides
the-
and projects, and
Yeah.
we'll do videos. Like I have to go back and redo all of these projects that we built. We're gonna
Yeah,
do videos and we'll show it off
one
every week.
one thing I'll say is
Machine
like,
Learning Monday.
yeah, I just like I couldn't get to the marketing and all the things I want to do with it. But the reason why I'm bummed is because this actually works. It's one of the few things like the demo where you hold up like pictures of a panda and it says panda. Like that's the 5-minute demo or the 5-second demo that you really want to show, especially a young person.
Yeah.
Like machine learning just isn't like find the leader of the group and kill and shoot them. Like machine learning it can be so much more.
Yeah.
So like some of the recognition things on different animals, that's really fun, especially for kids.
Yeah, and with Teachable Machine, the real secret was Teachable Machine. That we got that working like I think in January or February, because I remember one of the projects we did was like, oh, wearing a mask or not, and what's neat about it is that you can train it. It's the magic missing piece, which was how do you train TensorFlow to recognize objects that are not in the corpus. So like it recognizes a tiger and recognizes lotion, but it doesn't recognize you versus
Yeah.
me. Like how do you have it recognize two different people? You have to train it. And that training is really hard, but with Teachable Machine, we have a guide on it, and we'll port the guide over to the BrainCraft hat, and I train it to know you versus me, and it'll detect who's looking at it.
I don't recognize me most days. Okay.
Well, then it'll help you. It'll
Yeah,
say
maybe
you.
it'll help me out with that.
That's
Okay.
you, Phil.
All right, and with that is our.